value here is effectively R1. It's actually the sum of the R1s, which is it's all of the sum of all the ranks that are labeled as 1. So now we're ready to go. Let's just maybe just move on to the next page here, and let's just refresh what we have. So we know that n0 is equal to 5. We know that n1 is equal to 5. Now, it just happens that this is balanced, the same number of observations in both dichotomies. It doesn't have to be, okay? We have n is equal to 10, excuse me. And we also have the sum of the R1s, the sum of the ranks associated with the dichotomy labeled 1. What did we say that was? That was equal to 21. Okay, so it's equal to 21. So now we can calculate the correlation coefficient. So now we have that dr, the correlation of a dichotomy, a nominal variable dichotomy where a ranked variable is equal to, it's 2 times R1, so it's 2 times 21, minus n1, the size of the sample associated with the dichotomy label is 1, which is 5, times n, which is 10, plus 1, divided by the product of the two sample sizes. So it's 5 times 5 times n squared. We might as well, which is, I suppose, it's 10 squared, isn't that right? Okay. Minus 1 divided by 3, and it's the square root of that particular value. If you're interested in this formula, where it comes from, it is a transformation of the Pearson correlation coefficient under certain conditions, taking into consideration the ranks and the dichotomies, and Weary gives you a great exposition in relation to how this formula is actually derived. So maybe if I have a look for my calculator, I might be able to do this a little bit quicker. So what we have now is we have dr is equal to, well, we have 2 times 21, okay, minus 2 times 21 minus 5 times 11, which is minus 55, which is going to give us a value of minus 13. So we have a negative association here now so far, yeah. And then what we have as the denominator here is we have 5 times 5 is 25. 10 squared is 100, minus 1 is 99. So we have 25 times 99. So 25 times 99 is 2475 divided by 3. So divide that by 3, which gives us 825. So we've calculated the square root of 825. So RDR is equal to, it's equal to negative 13 divided by the square root of 825, which gives us a value of minus 0.45, which is a moderate association. Okay. We can probably ignore the negative sign, because I suppose it's really got to do with who we label as 0 and who we label as 1 in relation to the dichotomy. But effectively what we have here is the magnitude of this particular correlation would indicate that we have a moderate association. Don't forget, a weak association would be any R value that's less than 2. A moderate would be any R value that's greater than or equal to 2, but less than 5. And a strong correlation would be any R value that's greater than or equal to 5. That's a typical qualitative interpretation of the correlation. There's others out there. Okay? If I'm not mistaken, this one I think is by Cohen. I think this is Cohen's. It's either Cohen or, well, to be honest, it could go back to Pearson. Yeah, okay? But so maybe just ignore that. Okay? But there's many different ways to interpret this. But from this particular perspective, we have 0.45, which is that should mean 0.2, 0.2, 0.5. 0.45 is bigger than 0.2, but it is less than 0.5, so we have a moderate association. Okay, guys, once again, this was Jonathan Lambert with Maths and Stats, and I hope that this video, another video in our series of videos dealing with non-parametric correlation analysis, and specifically looking at a dichotomous nominal variable correlated against a ranked ordinal variable, I hope that this was intuitive, but more importantly, I do hope that was helpful for you, and thanks for watching. Okay, bye-bye.